right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 77 is on the screen, and today we're moving on. If you notice, I included some stuff that's coming back, some of it's fairly new, but most of it should be able to be completed. Number one says graph f of x equals 1 over x. We've been doing that since last week. Number two, f of x equals x squared, then transform or graph f of x equals x squared. Then transform according to g of x equals f of x plus 4 plus 2 over 3. Number three, rewrite each expression. Part A is a to the negative 2 power. Part B is 5 to the 0 exponent. Part C is 1 over x in parentheses to the negative 4 exponent. And part number 4 it says, if x to the third times x to the fifth is x to the 3 plus 5, which is x to the 8th, then rewrite 2 to the x plus 5 as the exponent. See if you can rewrite that. And number 5 says graph the circle x squared plus y squared minus 8x minus 4y minus 16 equals to 0. I'll give you guys some time for that. Copy and go. All right. So before I have you share with your neighbor, let me go over numbers 3 and 4 really quick. The other ones should have been a piece of cake by now, hopefully. Here goes 3 and 4. Number 3, it says rewrite each expression. Now I'm bringing these back. We saw these at the beginning of the school year. Been fat minute, some of you say, yeah. So, can we have a negative exponent on an expression? No. So how do we do that, Mr. Q? How do we change this? Well, if we set this over 1 and do the reciprocal, this becomes 1 over a, but instead of writing negative 2, I write a positive 2 as an exponent. That's how we change that. Or in other words, whenever you see anything with a negative exponent, you send it to the denominator over under 1. There it is. Part B. Now, part B, you should know by now. Because if you don't, I'm going to explain it again. 5 to the 0 exponent. Now, see if it triggers. Anything to the 0 exponent is 1. That is correct. Yeah, anything. X to the 0 exponent is 1. 23 to the 0 exponent is still 1. Anything to the 0 exponent is 1. Okay? C. Let's distribute the exponent to each of these to the numerator and denominator, so we end up with 1 to the negative 4th power over x to the negative 4th power. So far, so good, yeah? Yes. Can we have negative exponents? No. So what did I ask you to do? Do the reciprocal, yeah? So that means this becomes what? X to the positive 4 over 1 to the positive 4, which means x to the positive 4 over 1, which is just x to the 4th. Now I'm giving you practice starting today with these and also next week, because in 2 weeks from now we're about to get into logarithms, which are fun. It's pre-calculus, foundational stuff, good stuff, fun stuff. Yeah. Okay, good. All right, so here we go. Let's go to number 4. It says if x to the third times x to the fifth, since they have the same base, it becomes x to the 8th. Yes. So what happens to the exponent? That's why right here we have x to the 3 plus 5. Okay. So if that's how we got that, how can we rewrite this one? Let me help you out. If I write this at this step right here, 2 to the x plus 5, what was it before it became that? Talk it over to your neighbor. What was it before it became that? Talk it over to your neighbor, please. Yeah, good conversations. Yeah, good. I was just reflecting with the other period earlier. I'm like, I remember at Frank Wright, I used to tell you guys to keep it down, and I ask you guys to talk, and you guys don't want to talk. Came back crazy. It's like, anyways, never mind. All right, let's see. Help us out, Andy. What do I write here? 2 to the what? Yes, 2 to the x and 2 to the? Yes, that is correct. And 2 to the 5 is the same as 2 times 2 times 2 times 2, which is what? 32 times 2 to the x. And I'm going to leave it at like that. All right, now we can get to the graphing portion. The fun stuff, yeah? Yes, thank you. Very good. All right, so once again, I'm going to give you plenty of practice for this before we get into the locks, but that's foundational stuff. Here we go. So let me go over number 1, 2, and 3, and 5, sorry. Here it goes. Here's my coordinate plane. All right. All right, there you go. So, this one, what does it look like? Like this, and like this. Is that correct? Did you get a table going? Yes. So that means on your table you should have 1, 1, and -1, -1. Yes, at least, yes. So if you notice, this is a parent function. It doesn't have any transformations. That's why it goes through what? 1, 1. What does that mean, Mr. Yu? I'm bringing that up because this one is a parent function and it's a parabola, yes? And it's also going through what? 1, 1. The only thing, this one has a vertex at what? 0, 0. So the parabola looks something like this. Okay. But they want us to transform it according to this. You're like, looks kind of weird though, Mr. Q, because of the 3. Well, if I put an invisible 1 here, can I extract this fraction? Yeah, so this becomes g of x equals 1/3 times, what's left? F of x plus 4 plus 2. And this is to the second power, okay? So now do we know where it's going? Yes, it's going 4 to the left and 2 upward. 4 to the left, 2 upward. So before we move it, tell your neighbor what this 1/3 is going to do to the parabola. What is that 1/3 going to do to the parabola? All right, good conversations, my goodness. All right, help them out, please. Noor, what is that 1/3 going to do? It's going to compress, yes, vertically. If it was a whole number, it would stretch it. So here, instead of being 1, 1, it's going to be 1, 1/3. So that 0.11 becomes that. So here's my compression. Here's a little itty-bitty parabola right there. And now we can move it 4 to the left and 2 up. 4 to the left, 2 up. So it's going to end up somewhere over here. That make sense, yeah? Yes, Mr. Q. All right, last but not least, circle. Let's see, for this circle, we should have done completing the square, yeah, plus 16 to each side. And then you should have x squared minus 8x plus y squared minus 4y equals to 16. And then what completes this one? 16. What completes this one? 4. Therefore, my circle standard form equation is square root. This is x minus 4 squared plus square root y minus 2 squared equals, and what is this? 36. So, what is my center, everyone? 4, 2, 4, 2, 4, 2, somewhere over here. Okay. And what is my radius? Well, take the square root of this. So that gives us 6. So 6 steps in that direction, this direction, that direction, and upward. So my circle is somewhere over there. Yeah? Does that ring a bell, yeah? Yes, Mr. Q, I just did the pop party. All right, good. All right. Let's move on. Agenda for today. Warm-up number 77. We're moving on to rational functions. And tonight's home plate, pages 394, 395, odds only. You can find that in Canvas. I included a new module, so if you go to Canvas, whenever you go to Canvas, look through and you're going to end up seeing that there's a new module titled Rational Functions. New module titled Rational Functions. New module, Rational Functions. Yes? All right. You good, yeah?
Yes, thank you.
All right, good. And as we continue going, guys, through the school year, as we're finishing up second semester, I don't know if you guys noticed, we're adding more steps. Have you guys noticed that? Starting to get a little bit more intricate. And like for those of you that are like into engineering, like engines, you guys, who knows car engines? Somebody? In car engines, guys, an engine has a bunch of stuff. It's got from a distributor, injectors, pistons, valves, thermostat, water pump, gas pump. It's got so much stuff in there. And everything is put together in a precise way. So at the end, when you're assembling like the heads of an engine, you need to do it in a spiral way. Start tightening a screw starting from the middle, and then start going in a spiral way outward, and with a certain amount of pounds. Because if you don't, if you just do this one, this one, this one, this one, this one, eventually with all the pressure, it starts getting unbalanced because of the timing on the engine. And all of that all of a sudden creates water in the engine. All of a sudden you start getting oil in the engine. You start burning oil in your engine, and that's because they put it together the wrong way. So same thing with this, guys. As we approach more concepts, every little component that I've put together, guys, it's very tightly like this. It's locked. Make sure you stay focused and practice with me all the components. All right? Asynchronous code. No asynchronous code. Last night's home play or previous home play, that's free for you guys. Oh, thank you, Mr. G. You're welcome. Yeah, I got you. Yeah. That's pretty good, yeah. Okay. But tonight, once again, 394, 395 odds, and we're going to be graphing. So, hashtag till now for the end of the year, hashtag graphs. So those of you that love graphing, there you go. Anyways, tutoring after school, be there or be elsewhere. All right, here we go. Our objective for today, I can solve and graph rational functions. I can solve and graph rational functions. I can solve and graph rational functions. Solving and graphing rational functions. Today, though, we're just going to focus on the graphing portion. So I can solve and graph rational functions. Rational functions. I can solve and graph rational functions. What is our new concept? Rational functions. Now, we already covered rational expressions, and we touched into rational equations. Let me quick refreshment. Remember when we did cross multiplication of proportions? Those are rational equations. How about when we had an equation with a lot of fractions, and I said, let's find a common denominator, multiply the entire equation to get rid of the fractions? That's also a rational equation. Today we're moving on to rational functions. Okay? So what are rational functions? Rational functions! What are they? Let's find out. Rational functions are an equation that contains one or more rational expressions. An equation that contains one or more rational expressions. Well, rational functions are what? Equations, okay. And what else? Contain one or more rational expressions. So what are rational expressions? Well, first of all, what are rational numbers? Numbers that can be expressed as fractions. That means a rational expression is any expression that can be represented as a what? A fraction. Therefore, rational functions are equations that have fractions, that means one or more fractions. So let's look at the examples given. 6 over g plus 4 equals 2. 2x minus 14 over x squared minus 15x equals 1. 2x plus 6 over x squared plus 5x plus 6 equals 1 over x plus 3. Copy that. All right, so according to what we have in front of us, a rational function is an equation. Let's see, do we have equations? Yes. And do they have one or more rational expressions or one or more fractions? Yes, they are. There you go. Therefore, we know what they are. These are what they are not. Look at it. Don't copy that yet. Talk to the neighbor, why are these not rational functions? Why are these not rational functions, please? Why aren't they rational functions? All right, let's see. Lenny, the first two, why are these not rational functions? They aren't equations. How about this last one, Pamela? No fraction. Yes, that is correct. So, start off, hashtag equation, and then hashtag at least one rational expression. Yes. Now, as we approach, like I said, the latter or the concepts towards the end of the school year, I'm going to start giving you processes in steps so you can write them down, so you can at least have something to guide yourself with in case you get lost with the process. Yes? Here it goes. Write this down. Steps. Number 1, identify the vertical and horizontal asymptotes. Number 2, build an input-output table. And number 3, graph the function. Copy that. 1 minute. All right. So once again, steps. Identify the vertical, in parentheses, x, and horizontal, in parentheses, y, asymptotes. You're like, what is that, Mr. Q? Yeah, I'm going to explain that. Number 2, you should be able to be familiar with that. Build an input-output table. Do we know how to do that? Yes. And do we know how to graph functions? Yes, we've been doing that all year. Okay? So before we get more into that, let me take you back to when we started transformations. Writing your pencils down, look up to the screen. I gave you guys something that looked like this. General transformation rule. And it looked like g of x equals a times f of 1 over bx minus h plus k. You guys remember that? Yes? You're like, oh yeah, Mr. Q, my favorite. Okay, good. And we know what each component does. Is that correct? For the sake of time, k goes which direction? Up or down? Yes. H goes in which direction? Left or right? Moves our function left or right. A either stretches or compresses our function vertically. And B stretches or compresses our function horizontally. Yes? Okay. So that was in the past. Let's add more to it, yeah? So this is today. I mean, like, what? There's only one thing that's different. Only one thing that's different. So you know what that one thing is? See what it is there? Pretty good, yeah? Who sees that the only one thing different is that all of this is under the number 1, because now we're dealing with rational functions. Okay? So far so good? So before I give you this and explain each component now as a rational function, let me explain what asymptotes are. Asymptotes are a line that a graph gets closer to as the absolute value of the variable increases, or in Mr. Q's word, an asymptote is an invisible line that a graph will get close to but will never touch. You don't have to copy this, I'm just elaborating. Once again, what is an asymptote? An invisible line that our graph will get close to but will never touch. And the easiest way I can explain it, I don't know if you guys watched Star Wars, yeah, some of you? No? Okay. How about Independence Day? Have you guys seen Independence Day, the movie? No? The aliens or something? Anyways. There's something called a force field, an invisible force field that people can get close to but never can penetrate because it's a force field. In Star Wars, when they turn on their force field around the Death Star and here comes the next wing and it's getting close, It cannot penetrate because there's an invisible force field around the Death Star. So that means the airplanes can get close, but not pass or touch that field. Or else they would, like, explode or bounce off of it because it's an invisible line. And that's what asymptotes are. We're going to be talking about 3 of them, but today we're only going to introduce the 2 simple ones, known as vertical and horizontal asymptotes. Those are the simplest ones. Next week, we're going to get into the 3rd one, known as a diagonal, slant, or oblique asymptote. Those are the ones that require a little bit more work. And hint, hint, factoring and such. But now with rationals, yes? You're like, yes, Mr. Q. All right, we good? All right, write this down, please. General rule. We got g of x equals a times f, parentheses, 1 over b times x minus h, close parentheses, close big curve, parentheses, plus k. Copy that. Now, here's our general rule again, but this is for rationals. But we still know what each piece does. A, we know it stretches or compresses vertically. B, stretches or compresses horizontally. H moves our function either left or right. K moves our function up or down. However, for today, H and K play a second role. For usually those of you that are gamers, you know how you have your toggles and sometimes you press the B1 or R1 or whatever, and then you use the same toggles for something else. Same thing with this, right? Whoa, L1, my bad. Yeah. Or whatever the case. H does something else aside from move the entire function, so is K. So with your blue pen, point to H and label that vertical asymptote. And with your red pen, point to K, and that's our horizontal asymptote. Vertical asymptote, horizontal asymptote. So right now I'm going to give you some equations. We're going to do this together to make sure we get familiar with how to identify our asymptotes. Okay? So underneath this, I want you to write example 1. I'm going to leave this on the top right in case you haven't finished copying it. Get a coordinate plane going. Make it from -6 to 6 on both the x and y axes. And example 1 says identify asymptotes. I want you to skip Q, and we're going to do super Q. Y equals 1 over x minus 1 plus 2. Just copy that. Get your coordinate plane ready, and then we'll go over this together. Copy and... All right, we good? All right, so we're going to go over example super Q. Okay? So write your utensils down, you'll copy right after. Let me show you how to do this. Ready? Here we go. They want us to first identify the asymptotes. How do I do that, Mr. Q? Well, first, you're going to think about your general rule. Here's the general rule. I left it here. And see the similarities. What are the similarities? Oh, I see the x and the minus. The x and the minus. Okay. So by looking at it, I have an x and a minus, x and a minus. So that means my vertical asymptote should be, tell your neighbor. Okay, we have an x. Okay, I have an x. I have a negative. Yeah, there's a negative. So my vertical asymptote is 1. That is correct. However, from this point forward, look up. Instead of just writing VA equals 1, we're going to write x equals 1. Copy that. So if that's true, our HA, horizontal asymptote, according to this, is the K. So what is our horizontal asymptote? 2. But from now on, we're going to label it Y equals 2. Now, you're probably wondering, why do we write it like that, Mr. Q? Because we need to sketch straight lines using those 2 equations, dotted lines, to indicate that our graph cannot get close to those lines. So, for example, x equals 1. Where's x equals 1? Right here. So my vertical line going through that one in a dotted form looks like this. Do the same, please. My horizontal line going through y equals 2. Y equals 2 is right here. Horizontal, dotted line. There you go. That means my graph can get close to those two lines, but not touch them. Does that make sense? Pretty good, yeah? Okay. Straightforward?
Yes, Mr. Q.
All right. All right, let's do another one. Example mega cube. Y equals 1 over x, careful with this one, plus 3 minus, give me a number, 2. There you go. All right, identify your horizontal and vertical asymptotes. All right, so you remember the vertical asymptote and the horizontal asymptote for that one, please? All right. Vertical asymptote. Thomas, what'd you get? -3. That is correct. Hands if you got that. Yes. Because this is supposed to be a negative, but it's not. It's a positive. That means they substituted a -3. And our horizontal asymptote obviously is -2. So -2 of y is down here. Dotted line going through there. And vertical asymptote at x equals -3 going through -3 of x. Okay. So far so good? Yes? You're like, Mr. Q, this is cake. I know. All right. Do me a favor, look up to the screen really quick. I'm going to trigger your noodle. Look up. In the past, I gave you a rational expression that looked like that. And then I said, identify EV. Talk it on there, let them know what EV stands for. What does EV stand for? And what can I do? All right, good conversations. How about Adrena? What does EV stand for? Excluded value, that is correct. And what did we say was the excluded value is what made the denominator equal to 0. How do we identify the excluded value? We take the denominator, equal to 0, solve, so x equals 1. Why do we exclude that value? Because that's what makes it 0. Now, in the scope, look up, of what we are doing right now, look what we have. What was the excluded value?
1.
All right, good. Yes, the excluded value was 1. Why is that excluded? Because our graph cannot cross at x equals 1. That's why now it's an excluded value. Okay? All right. Or in other words, we can set each denominator equal to 0 and solve, and that's how we get our vertical asymptote. Let's test that. Let's see how we do with that. Ready? Copy this last one, and then you'll do some by yourself. Do Michael Jordan Q. Y equals 1 over 2x minus 3 plus 5. Identify the vertical asymptote. X equals and the horizontal asymptote y equals. Alright, some of you are like, wait a minute. That one looks different, a little bit different. Yes. So, say here for the vertical asymptote. What do you get for the vertical asymptote? Then I'll pick someone to help me. Alright. Good conversations. Vertical asymptote. Bree, what'd you get? 1.5? Yeah, 1.5. Yes, that is correct. Tell your neighbor how Bree got 1.5. Yeah, for these that the vertical asymptote is not as obvious because now we have this 2, we set it equal to 0, and we solve. Plus 3 plus 3, 2x equals 3, divide by 2, x equals 1.5. So whenever you have something that doesn't look like this, that it has a coefficient, then set it equal to 0 and then you solve for the x. Am I making myself clear? Does everybody see that? This one's fairly obvious. This one is not because now we have this 2 right there. Alright, so with that said, let's do some practice ones. Copy this, example 1, A, B, C, and D. And actually, skip 1A. We'll come back to that one. I want you to do B, C, and D. Let's see. Get it? Let's see how you do. B. Y equals 1 over 3x plus 9, and then plus 4. C, y equals 1 over x plus 7 minus 5, and D, y equals 1 over x plus 23 minus 23. Copy that. You don't have to plot and graph the asymptotes, just identify the asymptotes for those. I'll give you some time. Copy. Alright, let's see. Part B, Christian. Vertical asymptote, x equals what? Up more, Ricardo? -3. Hands if you got that. That is correct. That means the horizontal is 4. So far so good, yes? Part C. Vertical. X equals what, Andy? -7, which means our horizontal y equals -5. So far so good, yes? And the last one, x equals -23, and y equals -23, Michael Jordan. Yeah, we good? Alright, so, we're going to get into graphing now. We haven't gotten into graphing yet. We've been only on asymptotes. But that's the first step that we need for graphing. So before I go to graphing, look up to the screen really quick. Quick road trip as to where we've been with functions. Look up, please. You don't have to copy this. We started with linear functions, straight line. From there we went to f of x equals x squared, which is a parabola. From there we went to f of x equals x cubed, which is a cubic function. From there we went to f of x equals x to the 4th when we got to polynomial functions. Very similar to the parabola. And then right now our parent function f of x equals 1 over x. And we've been practicing the graphing on the warm-ups and they look like this. Is that correct? And what do all of them have in common? What all of them go through one specific point, which is 1, 1. 1, 1, 1, 1, 1, 1, 1, 1. All of them. All of them go through which point? 1 of x, 1 of y. All of them. Blah! All of them. Which means what, Mr. Q? That we're going to use that point to transform anything else that they're asking us to transform, such as this. Look up. If I did this, instead of being at 1, 1, this is now at 1 what? Negative 1. That's why it flips upside down. And it does the same to this one. Instead of being at 1, 1, it's at what? 1, negative 1, and it flips. How about this one? Flips. How about this one? Flips. How about this one? Flips, Mr. Q. Does that make sense? On all of them, if we put the negative there. And the reason I'm bringing that up, because on the home plate, you're going to have some negative 1. So if you graph it, and if it doesn't do the flip at the end, then you've made a mistake. All right, with that said, on your paper, copy example 1. Copy this, please. No, example, let's go to example 2. Too easy. We already did this one in the warm-ups. This one. Example 2Q, and it reads, graph the function, identify the domain and range. And it reads, y equals 1 over x minus 1 plus 2. Y equals 1 over x minus 1 plus 2. Set up a little coordinate plane. I'll give you guys a minute to set that up. Make it from negative 6 to 6 on both x and y. All right, here we go. Y'all ready? Step 1, I left the steps here that I gave you. Step 1 says identify the vertical and horizontal asymptotes. So the first thing I do, in blue, I'm going to write VA x equals, and then in red, HA y equals. I'm going to identify those and plot them on my graph so that I know that I'm not to cross those. So by looking at it, tell your neighbor what x equals and what y equals, please. Tell them what they are. All right, Lexi, x equals 1 and y equals 2. Hands, have you got that? All right, so let's plot those. X equals 1 is right there. And draw your dotted line going straight down through x equals 1. Okay, so our graph can get close to that, but not cross that, yes? All right, and then y equals 2. Y equals 2 is right there. That's a horizontal line. There it is. All right, now that we have that, we need to build an input-output table. That's step 2. So check this out. X, and in this one it's not f of x, it's y. Y. All right, but we need to identify a domain. Let me show you how to identify the domain to use. Look up to the screen, please, or you're going to miss this. First things first, I want you to identify where the vertical asymptote is at. Where is it at? At 1. That means I need to choose 2x values to the left and 2x values to the right of that. So tell your neighbor 2x values to the left of x equals 1. Good. Raymond, which ones?
2 and 1. 1 is 0 and 1.
Oh, 0 and negative 1. Yes, that's to the left. How about to the right?
2.
2 and 3. Okay. That's going to be our domain, people. Negative 1, 0. And I'm going to include 1, but what do I write for 1, everyone? Undefined. Tell your neighbor why. Why is 1 undefined? Good. Sky, why is it undefined? Because it's the asymptote. We cannot use the asymptote. We cannot touch 1. Okay? And then we use 2 and 3. Okay? So let's use our equation. Y equals 1 over parentheses minus 1 plus 2. And I'm going to substitute my first value, which is what? Negative 1. Okay? Y equals 1 over, what is negative 1 and negative 1? That's negative 2 plus 2. So look, 1 over negative 2 is negative a half, right? So what is 2 minus negative half? 1.5. Do it again. Y equals 1 over parentheses minus 1 plus 2. What's my next value? 0. So what is that 0 minus 1 is negative 1. So what is 1 over negative 1? That's negative 1 plus 2. So what is that? That is 1. Christian, you good? Yeah? Okay, good. Y equals 1 over parentheses minus 1 plus 2. And let's see. My next value is 2. Y equals 1 over, 2 minus 1 is 1 plus 2. What is 1 over 1? 1 plus 2 is 3. And last but not least, Y equals 1 over parentheses minus 1 plus 2. My next value is 3. What is 3 minus 1? 2. So that becomes 1/2 plus 2, so that is 2.5. Yes? All right. So with that said, let's plot that. Let's see. Negative 1, 1.5. Negative 1, 1.5. 0, 1, 0, 1. Hold on. And then you graph this side. Then we got 2, 3, 2, 3. And 3, 2.5. And that side. All right. Enjoy your homework, guys. Once again, pages 3. What was it? Whoa. 345, 346. Odds with graphs. Have a good one, guys. See you guys tomorrow. Bye. 394, 395. 394, 395. Bye, guys.